A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hello. Let us assume today is September 10, 2018. Here we can see some mountain ranges, correct? All the mountain ranges are blue due to the blooming of Neelakurinji. It looks like a blue blanket covering the whole mountain ranges. We all know that Neelakurinji blooms once in 12 years. The blooming of Neelakurinji forms a wonderful sequence. As the blooming year is repeating after every 12 years, it is easy to find out when will Neelakurinji blooms after 2018. That is, after 2018, after 12 years, Neelakurinji will bloom once again. 2018 plus 12, that is 2030. In which year before 2018 will Neelakurinji blooms? Yes, we must subtract 12 from 2018, that is 2018 minus 12, 2006. Prior to 2006, it is 2006 minus 12, that is 1994. If we know a single year when Neelakurinji blooms, it is easy to find out in which years they bloomed and in which years they are going to bloom. If we want to find out all the years on which Neelakurinji blooms after 2018, we must add 12 continuously to find that sequence. So here we get the sequences 2018, 2030, 2042 and so on. Similarly, if we get a sequence by starting with any number and adding a fixed number, it is called an arithmetic sequence.
We have already analyzed the sequence 1, 1, 1 by 2, 2, 2, 1 by 2, etc. This sequence is starting from 1 and increasing by 1 by 2. This is also an example of arithmetic sequence. The sum of external angles of any polygon is 360 degree. Starting from the triangle, if we write a sequence of sum of external angles of a polygon, the sequence will be 360 degree, 360 degree, 360 degree, etc. That is, this sequence is starting from 360 degree and increasing by 0. This is also an example of arithmetic sequence. Let us consider another example. If an object is moving along a straight line at 10 meters per second, let us assume if we apply a constant force in opposite direction, that is, the speed is reduced every second by 2 meters per second. So that is, for the first second the speed will be 10 meters per second, and for the second the speed will be 8 meters per second, and for the third second the speed will be 6 meters per second, and so on. That is, the sequences can be written as 10, 8, 6, 4, etc.
Here each of the terms is obtained by subtracting 2 continuously. Subtracting 2 continuously is same as adding minus 2 continuously, correct? So this sequence is also an arithmetic sequence. That is, an arithmetic sequence is a sequence in which we get the same number on subtracting a term from the term following it. The constant difference that we got by subtracting any term from the following term is called the common difference of an arithmetic sequence. The multiples of 4 can be written as 4, 8, 12, 16 and 20, etc. If we subtract any term from the following term, we will get the answer as 4. That is, 8 minus 4 is 4, 12 minus 8 is 4, 16 minus 12 is 4 and so on. That is, the common difference here is 4. So it can be said that the given sequence is an arithmetic sequence of common difference 4.
Now add 1 with each term of the sequence. That is, new sequence will be 5, 9, 13, 17, etc. Here also we can say that the common difference of this arithmetic sequence is 4.
Now let us consider the powers of 4. That is 4, 16, 64, 256, etc. There is any common difference here? No, right? The difference between the adjacent numbers is not a constant value. So the given series is not an arithmetic progression. So the multiples of 4 is an arithmetic progression, but the powers of 4 is not an arithmetic progression. Now let us consider all the sequences once again and find which of the sequences we considered were an arithmetic sequence.
The sequence of counting numbers is an arithmetic sequence. That is 1, 2, 3, 4, 5, etc. is an arithmetic sequence of common difference 1. So the counting numbers is also an example of arithmetic sequence. The sequence 1, 4, 9, 16, etc. is not an arithmetic sequence because this sequence does not have a common difference. The sequence 4, 6, 8, 10, etc. is an arithmetic sequence. If we analyze this sequence, the common difference of this sequence will be 2. The sequence 1, 2, 1 by 4, 4, 6, 1 by 4 is not an arithmetic sequence because there is no common difference.
Now what is the next term in the sequence 3, 5, 7, etc.? Here it is not given that the sequence is an arithmetic progression. If it was an arithmetic progression, we could easily answer the next term as 9, correct? Then if the given series is series of odd prime numbers, then the next term of 3, 5 and 7 may be 11. We know the prime numbers are the numbers which have two factors, that is the number itself and 1. So 3, 5, 7, 11 are odd prime numbers. So by two different rules, we got the next term as 9 and 11. What is the conclusion here? If some numbers are written in some particular order, we won't be able to define the next number in the sequence. The rule or situation that used to define the sequence must be known to find the next term of the sequence.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.